Hello friends, welcome to my YouTube channel. Today we will walk through a set of very interesting NumPy functions which will make our life easier. So without any further delay, let's get started. So the very first function is np.arange and it returns evenly spaced values within a given interval. So if you run this particular cell np.arange by giving the parameter 10, so it will return 10 values starting from 0 to 9. So that's np.arrange for you. So next comes np.arange, but we need set of numbers, say like between 1 to 12, and it should have a difference of 3. So basically it returns evenly spaced values within a given interval. So if we say like np.arange, and if you do a shift tab within the function, then we can say it accepts three parameters: the start, the stop, and the step. So we want to start from the value 1 and we want to stop at the value 12, and we want it to be done in steps of 3. So it returns 1, 4, 7, and 10. The next function is the function linspace of NumPy. So it returns evenly spaced numbers over a specified interval. So let's see into the help function of linspace. And as we can see, like it takes a lot of parameter, but the first three parameter that we have used over here is like the start, stop, and the number of values to be returned. So over here we are saying NumPy to return 10 values between 0 and 1 in such a manner that it's evenly spaced. Next is like np.linspace, but I would like to point out to this very interesting parameter, which is the endpoint. If you put endpoint as false and you run this, then it will return you like 4 values between 0 to 2 without keeping 2 as the end value. So if you remove this, it will keep 2 as the end value and will return 4 values. As you can see, 0, 0.66, 1.33, and 2. So that's the use of the parameter endpoint equal to false. Next, we have np.ones. So as the name says, it will return your new array of given set and type filled with ones. So say like we want to create a 4 by 4 matrix which has all ones in it, but the dimension of it should be 4 by 4. So we can run this function and we can get the matrix of all ones of the shape 4 by 4. Next, we'll be looking into a new function which is very similar to np.ones. It's np.zeros. It will return you a zero matrix of the given dimension. So say like you want a zero matrix of 2 by 2. So you just need to run this command np.zeros 2 by 2. It will return a matrix of dimension 2 by 2 with all the values as 0. And you can also do 2 by 3 and you will get a zero matrix of the dimension 2 by 3. Similarly, if you want a matrix with only the diagonal elements as 1 of a particular dimension. So over here np.eye will return a matrix with the diagonal elements as all ones of a given dimension. So say like if you pass over here as 4, so it will return a matrix of 4 by 4 with the diagonal elements as all ones. So let's try something like 4 by 5. Okay, if you see like if you pass the rows and columns, then also it tries to maintain the diagonal elements as all ones. But since it's not a square matrix, the last column is set as 0. So that's the power of np.i. Yeah. Finally, we will look into this very interesting matrix, which is np.diag, which basically what it does is like it will extract a diagonal or construct a diagonal array. So if you see what it does is like it will take a set of values and it will put it in the diagonal elements of the array. So if you see when we say like np.array 1, 2, 3, 4, it automatically understands the dimension of the array should be 4 by 4 with the diagonal elements as the value 1, 2, 3, and 4. So those are like the very interesting functions of NumPy that we use. Thanks for watching the video.